In this video, we're going to learn how to solve exponential functions. Now, the key to solving exponential functions is to get an equation that has two exponential functions on it, each with a similar base on each side. Because if that's true, then the powers must be equal to each other in that instance. So if a is to the u is equal to a to the v, then u and v must be the same number or expression. So here, if I have 3 to the x plus 1 is equal to 81, right now these bases are not the same. 81 can be rewritten as 3 to the 4th power. If you ever have a hard time envisioning why that is, you can always make a factor tree and break down what 81 is by saying what things multiply to 81. 81 is 9 times 9, and each 9 is 3 times 3. And once you can't go any further, you've reached the prime numbers of each multiplication before it. This would just be 3 times 1. We have to stop here and just count what all those numbers are. And 3 times 3 times 3 times 3 is 3 to the 4th, which makes up that 81. So don't be afraid to use a prime factorization if you get stuck on what a number could equal. But here I have 3 to the x plus 1 is equal to 3 to the 4th, which just means that x plus 1 is equal to 4. Solving that, you get x is equal to 3, which is the solution to the equation. That would be 3 to the 3 plus 1, which is 3 to the 4th, which is 81. Now, let's say we have 4 and 8. Now, 8's not a power of 4, and 4 is definitely not necessarily an easy power of 8. But what I do know is that 4 is 2 squared, and 8 is 2 cubed. And by doing this, I'll have a common base. But using the law of exponents, I need to multiply the exponents that are there already. So 2 times 2x minus 1 is 2 to the 4x minus 2 is equal to 2, and then 3 times x plus 3 is 3x plus 9. Now they have a similar base. I can set their exponents equal to each other. Then I can subtract 3x, give me x minus 2 is equal to 9, add 2, and x is equal to 11. So when x is 11, these two expressions are equal to each other. Now let's look into maybe a more complicated situation. Now we have a fraction, but let's see if we can rewrite this. We have e to the negative x squared is equal to e to the x squared, so you multiply those exponents, so it's e to the 2x. And 1 over 3 can be rewritten as e to the negative 3 by moving it to the numerator, using that law of exponents. Now, combining these two bases, I add them together, so I get e to the negative x squared is equal to e to the 2x plus negative 3, which is minus 3. And now I have a similar base, so I can set the exponents equal to each other, and now I have an exponential equation to solve. I can add x squared to the right, give me 0 is equal to x squared plus 2x minus 3. And then I can factor, give me x plus 3 times x minus 1. And I can say each of those factors equal to 0. They give me the two solutions of negative 3 and 1 as possible solutions. So sometimes you'll end up with a quadratic or cubic equation to solve once you've combined everything. So this last one here of 9, 27, and 3, which I can treat very similarly to this bottom left example. 9 and 27 are both powers of 3. So what I can do is rewrite 9 as 3 squared. 27 I can rewrite as 3 cubed. And then this is just 3 to the negative 1. So 2 times 2x is 3, gives me 3 to the 4x. 3 times x squared gives me 3 to the 3x squared. And then equals to 3 to the negative 1. I can combine both these bases by adding their exponents since they have a similar base. So I get 3 to the 4x plus 3x squared equals 3 to the negative 1. And now that I have a similar base on each side of my equation, I can set 4x plus 3x squared equals negative 1. I can add 1 to the left and rearrange my terms to put it in standard form. So I have 3x squared plus 4x and then plus 1. And now I need to factor this quadratic, which can factor into 3x plus 1 times x plus 1. And then I can set each of these factors equal to 0 to give me the two solutions of negative 1/3 and negative 1. Now, let's get into some like relating problems, meaning if I know that 2x to the x is equal to 3, then what could 4 to negative x equal? Well, the trick to this one is to hold on to this information that 2 to the x is equal to 3, then find a way to rewrite 4 to the negative x to maybe include 2 to the x. So 4 I know is 2 squared, so I can write 2 squared to the negative x, which I can multiply together to give me 2 to the negative 2x. And very creatively, I can rewrite that as 2 to the x to the negative 2. Now that I see this, I can replace 2 to the x with 3. So I have to have 3 to the negative 2, which is the same as 1 over 3 squared, which is 1/9. So 4 to the negative x should equal 1/9. So you're looking for a pattern to connect those two variable expressions so that you can just replace 2 to the x with 3, and that'll give you the value of 4 to the negative x. So over here I have 5 to the negative x is equal to 2. So what does 5 to the 3x equal? Well, right now it's not just 5 to the x. So one thing that might help me is actually to rewrite this expression to help me find my answer. So what I can do is rewrite this as 5 to the negative x raised to the negative 1 power. So I have to do 2 to the negative 1 power as well. So when I multiply the exponents, that just gives me 5 to the x. And then 2 to the negative 1, which would be 1 over 2 to the first, so 1/2. So 5 to the negative x just is equal to 2. It just means that 5 to the x is equal to 1/2. So when I see this expression, I can rewrite it as 5 to the x raised to the third power, which is the same as 5 to the 3x. And then I can replace 5 to the x with 1/2, since I just discovered that. So I get 1/2 to the third, which is 1 cubed, which is 1, and 2 cubed, which is 8, so 1/8. So 5 to the 3x is equal to 1/8. And that is how you solve exponential equations.